check out that graph. This is the graph of the piecewise function f, very strange function, and this is g. And they're asking us to find each of these. So, quick tour. Sometimes they ask for f, sometimes they ask for g. That's why it's always important that when you write these, when you write down the limit as x approaches whatever, you talk about what function you're dealing with. Whether you put the equation or whether you put the function itself or the expression or the function itself, we need to know what you're referring to, because sometimes it's the graph, sometimes it's the expression. Okay? So, let's do it. The limit as x approaches 0 of f. Well, let's grab 2 pens so we can approach. We're going to approach 0. X value of 0, I'm going to go to the function itself and go, the answer is 1. Now, you could have been like, 1. I get it. You're right. You're not wrong. It's 1. Okay, I want to approach a -3 for this. Option number 1, at all times, can I use direct substitution? And the answer is yes. So -3 minus 2 is my numerator, absolute value. -3 minus 1 is my denominator. So I have a -4, I have a +5. That's it. We're done. Totally done. Don't have to do anything else. I want to approach a 4 on the f function. And as I approach 4 on the f function, again, I'm dealing with the graph. Here's 4. We're approaching an x value of 4, tracing the function. Boom! What's that logical y value? Well, it's the value of the function, which is itself -1. Okay, now things get tricky. I want to approach a 3 on the f function. X value is 3. So we're going to get closer to an x value of 3 by tracing the function from either side. And hopefully the ink pens will match up. And they don't. No! Because this left-hand limit is approaching a y value of 4. And the right-hand limit is approaching a y value of 3. And therefore the limit does not exist. Okay, now we're going to approach -3 on the f function. So as I do that, grab my other pen. I'm going to start going a little faster because I think we get the hang of this. So we're going to approach -3. So we're doing this. Y value is 2. There we go. The y value is 2. And for this one, we have 5 times the g function. Okay, the next lesson deals with the properties, but I'm going ahead and introducing them to you now. And here it is. I want 5 times the g function. Another way of looking at this, totally legal to do this, I could say I want 5 times the limit as x approaches 1 of g of x. I can do that. So I could multiply all this by 5 and then figure out the limit, or I could say, you know what, let's figure out the limit and then multiply this by 5. Either way, you're going to get the same answer. I just choose to put the 5 in the front because I want to, because that's how I roll. And so then I'm going to plug a 1 in to this function if I can. Oh, I can't. I can't. So let's figure this one out. Let's go with the table. That's just what I like to do. And as I do, let's see, I need absolute value. In case you never knew how to find absolute value on the calculator, press math. Go over to number. It's the math button right there, by the way. Go over to number, and it's the top option, absolute value. And x minus 2, oops, divided by parentheses, x minus 1. Okay, we're going to approach an x value of 1. We're going to go to the table and do so. We have a lot of old stuff in there. We can just keep pressing delete until they're gone. Are they gone? Are they gone? No, they're gone. Okay, we're going to approach a value of 1, so like 0.9. 0.99, 0.999, 0.9999. Okay, I think you're noticing what I'm noticing already. So -11, -101, -1,001, -10,001. Cool number pattern, but we're decreasing without bound. And if we were to approach an x value of 1 from the other side, so like 1.1, 1.01, 1.001, 1.000, we are increasing without bound. And so we are not able to really nail this down anywhere. The limit does not exist. So we have 5 times something that doesn't exist. So at this point, the 5 is irrelevant. I'm just going to mark that out and pretend like I never wrote it. Does not exist. Simply does not exist. And I don't say equals does not exist. It doesn't equal does not exist. Does not exist is not a number. In case you really care, I want to see a graph. There we go. You have a vertical asymptote. The absolute valueness kind of throws us off and it makes the asymptote sneak up on us, but there it is. Okay, this next one is another property you're going to encounter in just I almost said a few minutes, but in the next lesson, depending on when you watch the next lesson. So this is really the same thing as saying, well, I need the limit as x approaches -4 for f. We'll figure that one out. And I also need the limit as x approaches -4 for g, and we're going to figure those two out separately and then add them together. This is just a neat thing. You could say I'm distributing the limit. Technically you're not, but the concept kind of looks the same. So as we approach -4 on the f function, again that's the graph, we are looking at -4, the y value is 1, the limit is 1. The y value is also 1 for the function, but the limit doesn't always match the function. And then if we plugged in a -4 into the g function, which is totally okay, we can do that. If we plugged a -4 into the g function, using direct substitution, we'd have -4 minus 2, there's your numerator, and then -4 minus 1, your denominator. So we're going to have 6 over 5, -5. So we're going to have 1 minus 6/5, and that's going to give me -1/5. I ran out of the box. Sorry about that. Okay, notice this next one. You might look at this one and say, well, we distributed, again, I use that loosely, we're not technically distributing, but we distributed the x approaches -4, the limit part. But here we're not, okay? I need the limit as x approaches -2, all right, fine, plus the actual value of the function at -2, the function f at -2. Okay, this one is a limit. This one says evaluate the function. They're two separate ideas. Notice that the parentheses here grouped this together to where you were finding the limit of both of these. Here you're finding the limit of the first one and evaluating the function at the second one, which does happen to be the value of the limit. Oh, wait, no, it doesn't. I was looking on the wrong side. We'll get there in a second. Okay, -2 is going to go into the g function. So -2 minus 2, absolute valued, over -2 minus 1. We'll figure that out in a second. Plus f of -2. I might be tempted to say, well, my function is broken. My graph is broken at -2, and it doesn't match from the left and the right. No, 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 no. They're not asking for the limit. They're asking for the value of the function at -2, which is 1. So, 1. All right, that's 4 in the numerator, -3 in the denominator. 4 over -3 is going to give me that. And I end up with, oops, I put equals. -4/3 does not equal 1. Silly math teacher. -4/3 plus 1 is going to give me -1/3. There we go. Okay, the next two problems are a little bit tricky and worded in a very strange way, and they deal with the f function. I hope we notice that. So we're done with g. But I want to state every value of a. Okay, what's a? Let's keep reading. For which the limit as x approaches a. Okay, pause right there. If you seem overwhelmed with a problem, read it carefully. State every value of a for which the limit as x approaches a. I am going to give you a list of x values because x approaches a. A, in this context, is going to be x values. Final answer will be a list of x values for which the limit as x approaches some x value for my function f, graphed, is equal to 3 on the interval from -6 to 6. So what I did was I found something that I thought would come in very handy, and here it is. Dental floss. It's random that you weren't expecting me to say that, were you? I want to approach a y value of 3. I want my answer for the limit to be 3. Right there. See the floss, okay? Kind of hard to see in this lighting, but there's your floss. I want to know every time my function approaches from both sides that dental floss, which is laying across the y-axis at 3. All right, let me see if I can keep this dental floss in the same spot. As best as I can. I can't, but I'll try. Okay, there's one right there, where my finger is. There is not one right there. Oh, but the function is, no. The function does not approach the dental floss, a y value of 3, from the left and the right, just from the right. And then it also happens here. So the answer is an x value of 2, not an x value of 3, and an x value of 5. All right, let me move the floss out of the way and show you again. I want a y value of 3. Yes. No. Yes. Final answers are a equals 2 and 5. Same question. We're dealing with b values now. And I want to approach a y value of 1. All right. I'm going to use a pencil this time. The floss was a little bit unwieldy. Okay. Y value is 1. So let's try it. Yes. No. We're approaching two separate y values. One of them is 1, but the other one is not. Yes. Yes. And yes. All right, let's find our yeses again. Yes at 4, negative 4. No. Yes at 0. Let's start writing. Negative 4, 0, 2 more. Here and here. And this one is at 3 and a half. And if you're like, I don't know if it's exactly a half, are you sure it's a half? Look at the slope of this line. This little line and this one also both have a slope of negative 4 or positive 4. And so I'm going down 4 and over 1, but I really would be going down 2 and over a half. See, notice the slope. So this is 3 and a half. This is 4 and a half. So 3 and a half, 4 and a half. These questions are asking you to find the x values when given the limit, the y value. Everything we've done up to that point was asking for the y value with an approaching of an x value.